Hi, I'm Vinod Kumare, studying in Department of Electronics and Communication Engineering, Sri Venkateswara College of Bangalore. Today we are going to discuss about solar space cooling of building. The black diagram of solar space cooling building. The absorption air conditioning system is shown in the above figure. The system consists of two parts. One is the solar collector and storage, and the another one is absorption air conditioner and the auxiliary heating. The essential components for the cooler are: the first one is generator, second one is condenser, third one is evaporator, fourth one is absorber, and fifth one is heat exchanger. The operation of air conditioners with energy from flat plate collector and storage systems is the most common approach to the solar cooling today. In essence, cooling is accomplished as the generator of absorption. Cooler is supplied with heat by a fluid pumped from the collector, storage system, or from auxiliary. Heat is supplied to a solution of refrigerant in absorbent in the generator, where refrigerant is distilled out of the absorbent fluid. The refrigerant is condensed and goes through a pressure reducing valve to the evaporator. When it operates and cools air or water from the cooling space, the refrigerant vapors goes to the absorber where it comes in a contact with solution which is weak in the refrigerant and which flows from the generator. The vapor is absorbed in the solution which is which is then turned into the generator. The heat exchanger is used for sensible heat recovery and greatly improves cooler COP from the point of view of use of a conventional energy source. There is a single index of performance for rating cooling process, that is the COP, the ratio of the amount of cooling to the energy required. For solar operation, there is two additional factors: the temperature required in the solar collectors to drive the process and the ratio of cooling produced to the solar energy incident on the collector. As solar process are inevitably transit, transit in their operation, the energy ratios and temperatures will vary with time, and COP based on long term integrated performance provides an appropriate index of performance. Pumping to more absorbent solution may be by mechanical means or by vapor lift pumping in the generator. For low pressure systems like lithium bromine water systems required water cooling of absorber and condenser systems. Systems of this type shown in the above figure have been the basis of most of the experience to date with solar air conditioning. The coolers used in most experiments to date are lithium bromide water machines, water coolant absorber, and condenser. The pressure in the condenser and generator is fixed largely by temperature drops across heat transformer surface in the generator and condenser. The pressure in the evaporator and absorber is fixed by the temperature of the cooling fluid to the absorber and by the temperature drop across the heat transfer surface in the evaporator and the absorber. Thus, to keep the generator temperatures within the limits imposed by a by the characteristics of flat plate collector, the critical design factors and operational parameters includes effectiveness of the heat exchangers and coolant temperatures. The common practice in solar experiments has been to use water cooled absorbers and condensers, which in turn requires a cooling tower. Thank you.